Hi, this is Michael Ellis, also known as Eli the Artist, and today I'm going to teach you how to make what I think is gold. I'm not sure, so don't quote me on it. Excuse me, I have hiccups. Um, what I think may be gold, I'm not 100% sure. Gold and silver, maybe. Um, Something that appears. Oh, I'm sorry, I have hiccups. To be a little more than just plain yellow iron oxide, but it could just be yellow iron oxide for all I know. But something more than that, it appears to be. I've got all the right combinations of setups for what should be a natural gold mine, and um, I'm hoping that it actually is, but I haven't tested it yet, so I can't say for sure that it's actual gold. But bear with me, and I'll show you the process, and we'll see what it is. So so to begin with, we're gonna have to actually get our iron stock. So we're gonna start with iron. Now, to get the iron to the smallest, most surface area possible, and to get the most iron that we possibly can, to make the highest quantity of our end product possible, and we begin with electrolysis. So right here I have some rechargeable batteries, 9 volt. I have 4 of them, and I have them in series. So I just connected them together. Now the only thing you got to be concerned about is that these may overheat. So you got to be careful with them. But they should be okay with normal tap water. So just connect them in series, attach alligator clips to them, and here we have our electrodes in a pickle jar. That's what I had on hand, and we have 2 iron electrodes. You can use whatever you want for the negative pole, just using iron on the positive. And as you can see, it's already bubbling. It's starting to cloud the water, which is a good sign. It'll start off yellow and then it'll turn green. You don't want it to turn black, but it might turn black. That's fine if it heats up too much. So we've got it started, and so actually what I did was I taped the electrodes to the sides of the jar, so we can get the so we don't get them contacting each other, because if they short out, that's a bad situation. There's sparks, and the batteries overheat and everything. So and the wires may melt and stuff like that. So a lot of bad stuff happens when they contact each other. So make sure you tape the electrodes to the sides of the jar. I just used some duct tape. I just used regular tap water, cold tap water. You don't want too much salt in there. That may hinder our process later on when we try and melt it back down. You don't want too much salt in there because it creates fumes that are nasty, the hydrochloride fumes. When we're trying to distill it back down, it creates the hydrochloride fumes out of the distillation unit. We just keep doing this for about an hour or two until till it about stops producing more of the colloid. So it'll turn green and then white and then maybe black. But once it stops producing the stuff, then we'll disconnect it and pour it into our flat bottom, round beaker, boiling beaker, flask, whatever you want to call it, or not a beaker, a flask, boiling flask. Add a little bit of copper shavings in, add some salt, add some dirt, and then put on our distillation arm, put on our receiver, and cap it off. Our receiver is actually loosely connected through some whatchamacallit, and you'll see this later on. There's some plastic wrap. That's just how I do it. We always want to keep a positive pressure on the distillation. That's the secret to making gold, I've discovered. And so on, and so you'll see all this later. But right now I'm going to pause this, and we'll see the rest later on. So you see everything that's happening high, and with this electrolysis is going on. So we've got the two iron. So these are basically nails that are not galvanized. So you want to make sure they're not galvanized because of the otherwise you'll get like zinc, and zinc can produce some nasty fumes when you electrolyze it. Supposedly, that's what I've been told anyways, but I don't think that's the case, because there's tons of people that are doing zinc electrolysis with the Keshi stuff, so and they're not getting sick. So supposedly that's a myth. Anyways, but yeah, supposedly you don't want to do zinc electrolysis because it can do some nasty stuff, maybe with the salts in the water or something like that. But supposedly that's a myth. So as you can see, we're turning green now, and that's the iron. I don't want to say it's iron hydroxide because I don't know for sure, because this is really a colloid more than a hydroxide. But chemistry would tell us this is an iron hydroxide, but in reality it's more of an iron colloid that is green, or a blue and a yellow iron colloid, which I just referred to as the green stuff. This is the green stuff of the Holy Grail, of the Sword and Stone, stuff like that. So yeah, so Christmas, red and the green. The red would refer to the red iron, and the green to the green product. Or if you actually turn this into the gold product later on through a different process, actually, then it'll turn green in the salt-free state and red in the salted state. So those are just the red and the green references. But we've got the green iron colloid, the green of the emerald, of the Holy Grail, of Lucifer's stone that fell from heaven, the emerald cup that is spoken of. So with this, I shall stop, and we'll just let this run, and when it's done, our batteries aren't heating up too bad. No heat there, so I'll stop it here, and we'll resume later when it's done electrolyzing.